Good morning to everyone. My name is Sheikh NIZMI, working as an assistant professor in S.A.ENGG Engineering College. I am from the Department of Artificial Intelligence and Data Science. Today I am here to give you a brief note of basic sorting techniques in data structures. Let us see them. So what is sorting? Sorting mainly refers to the rearrangement of elements in a particular order. Sorting mainly refers to the rearrangement of elements in a particular order in accordance with the comparison operator. So what this comparison operator will do is it will give us a new order of elements with respect to the particular data structure. So from here, sorting means it's nothing but arranging the given set of data in particular order. So from the screen you can see here there is an unsorted list as well as the sorted list. So once the list is getting sorted by using any sorting technique, it will convert into either a sorted list either in a ascending or a descending order. So the basic types of sorting. So as we have discussed, we are mainly using this comparison operator to do the sorting technique. So we have two different kinds of sorting techniques. One is based on comparison and other one is non-comparison based. So in comparison based we are having 6 sorting techniques, and in non-comparison based we have 2 sorting techniques, like bubble sort, insertion sort, selection sort, quick sort, merge sort and heap sort comes under comparison based, and counting sort and radix sort will come under non-comparison based. So why we are doing this sorting? So mainly we are doing this sorting to reduce the complexity of any problem. Complexity is nothing but the difficulty level in solving any problem. So, and also we have wide range of applications in this by using this sorting. Like we can use this in searching techniques or else in divide and conquer algorithms. So there are wide range of applications for this. And also when we are using hundreds of data sets, we should know a particular order, or the data should be arranged in a particular order so that it can be retrieved easily whenever we need. So by using this sorting, the main thing here is we are converting the data either in ascending or descending order, with which it will be efficient. By using simply by using a binary search itself, you can easily retrieve your data. And as you know, like for any problem, it ends up with some set of difficulties or issues. Likewise, the issues in sorting will feel difficult in the sorting, like how to rearrange the given set of data, because we'll be dealing with many different kinds of data. So it will be difficult for us to rearrange the given set of data, and we should know, we should have a good idea of how which data structure to be used once the list or array it will get sorted, and also how fast the sorting technique will be, how efficient it is to do the process, and also how sorting can be done if there is a memory constraint, like if the memory is not good enough for the elements to be get sorted and once saved into the memory, then also it will raise a problem, like how we are going to put it in a proper order. And also different types of data sets, we have to deal with different types of data sets, like either it is a positive numbers, if it is numbers, either positive, negative, or there may be many conditions. So first we'll talk about the basic sorting technique, which is a bubble sort. So in this bubble sort, what we are actually doing is we are proceeding the iteration process of comparing the adjacent elements, adjacent neighboring pairs with the help of passes, different passes. This bubble sort will be done in different passes. Like if you see here, we are comparing the neighboring pairs that to be swapped if they are not in particular order. Then the when after every pass, the elements under considering will be, once the elements get bubbled, there will be the highest element will go to the last position at the end of each pass. That is, from here you can see in every iteration the heaviest element drops at the bottom and the bottom moves upward. This is the main principle of bubble sort, where the heaviest iteration, where the element in every iteration the heaviest element will drops to the bottom and also the bottom moves upward. And also when we are talking about bubble sort, the algorithm mainly proceeds with two steps. The first one is we have to compare the adjacent elements, and if the elements on the right side is smaller than the element on the left side, then the elements will get swapped. And also the second thing is compare the first element, second element, and like this the comparison of the elements will go on till the completion of first pass will be ending up with the largest element to the last position. Now let us see the working example of bubble sort. And also here number of passes. So how can we determine how many number of passes should be done? We have a simple notation for it, like number of passes is given by the size of the array minus 1. In pass 1, if we consider the index, we have to consider index 0 to n minus 1. In pass 2, we should consider index 0 to n minus 2. Like so on, in pass n minus 1, we have to consider from index 0 to 1. Now let us see the working principle of bubble sort. See, if there is an array X with some set of elements, then we should start with the first element. Here 3 and 2, 12. These two elements are getting compared, and here as you can see, the element on the right side of 3 is 12, which is the largest element, so there is no need of swapping there. Then we'll come to the next step, that is the other neighboring set of elements are being compared, like here from 12 and minus 5. Obviously minus 5 is less than 12, so it comes to the left position. So and so on, this process will continue till we'll be ending up with the largest element, that is 72, will be going to the last position in the pass 1. But as you can see here in this list, it is not already sorted. Even though we have done the first pass, but the list is not getting sorted. So we have to continue with the next pass. So here the same process will repeat, that is we are comparing the two elements, the first two elements and then the next set of two elements. Like that the process will continue until we are getting a sorted list of elements. Now let us see a small C programming code for bubble sort. Here we are writing two functions, one is swap function and one is bubble sort, function for bubble sort. So what the swap function will do is, it will swap the elements. Here we are taking the pointers of x and y, where the elements in the position of x and y will be swapped with the help of a temporary variable. In the next one, we are writing a function for bubble sort, where we are sending the array and the size of the array as the parameters, and here by the code we can see we have to write two for loops. The outer for loop is to find out how many passes we have to continue, and the inner for loop is mainly for comparing the two elements, and also in this inner for loop we will call the swap function. If there is a need, we can swap it. So here is one example program. You can see here where x is an array of elements, where here we are considering both positive and negative elements, and here first we are trying to print the array as it is, that is without any change. For that we are writing one for loop from for I equal to 0, I is less than the size of the array, I plus plus. Here we are printing the array as it is. Now we are calling the bubble sort function, which indeed helps us to sort the elements in a particular order, and then we are printing the result by using the another for loop. So here from the output you can see when the list is printed as it is, the numbers are not getting sorted. So once the sorting has been done, by using the bubble sort function, we get the elements in a proper order. Now let us talk about the complexity analysis of a bubble sort. Complexity is nothing but the amount of time or memory you are using. Like it is required to solve any problem. The amount of time and memory which is required to solve any problem. Like in the bubble sort, if we see, we will talk about this in three cases. Like the first one is if the input list is already in a sorted order, then the number of comparisons and the number of movements will be given as C of n is equal to n into n minus 1 by 2. That means we have to do these many comparisons even though the list is a sorted one or unsorted one. And also the number of movements is given by m of n is equal to 0, because the list is already in the sorted order, there is no need of further comparisons. So here m of n is 0. Now in the second case, if the input list is not in a sorted order but in a reverse order, then the number of comparisons can be given as C of n is equal to n of n minus 2 by 2, and the number of movements will increase here because the list is in reverse order. Here you can see the number of comparisons is equal to number of movements. In the third case, if the input is in random order and the number of comparisons can be given by C of n equal to n of n minus 1 by 2, and the number of movements will be, if we consider Pj is the probability of the largest element in the unsorted part, then which is located in the jth location, then the average number of swaps in the ith pass is given by this formula, where n minus I plus 1 represent the amount of pass to be done in the jth location. So here, as we can see, the probability of each element in all the swaps is remaining the same. So we can take it like P1 equal to P2, that is equal to Pn minus I plus 1 number of swaps, that will be equal to 1 by n minus I plus 1. So therefore, the average number of swaps in the ith pass will be given by this formula. Here, summation of j equal to 1 to n minus I plus 1, 1 by n minus I plus 1 into n minus I plus 1 minus j, that is equal to n minus I by 2. So the average number of movements is given by n into n minus 1 by 4. Let us see the summary of complexity analysis for a bubble sort. So here in the case 1, like we have seen the three different cases of bubble sort. First one is if the input list is in sorted order, and the next one is if the input list is in the sorted order but in the sorted list is in a reverse order, and if the input list is in a random order. So for the case 1, we can see from here C of n is equal to n into n minus 1 by 2. This is the number of comparisons, and this will be same in bubble sort for each case. And the moment m of n equal to 0 for the first case, and for the second one where the list is in the reverse order, m of n is equal to n into n minus 1 by 2, and the memory space will be s of n is equal to 0. So likewise, the same case for the list is in random order, m of n is given by, the movement is given by n of n minus 1 by 4, and the memory will be given by s of n is equal to 0. So from here you can see the complexity for different cases here. For the case 1, the time complexity will be order of n square, and also for the case 2, order of n square. So the best case, worst case and average case, in these 3 cases per bubble sort, the time complexity will be order of n square, which is the main drawback of bubble sort. That means even though the list is in sorted or unsorted order, we have to do these many comparisons, and also the time complexity will be more, that is order of n square. No, so for this we are using insertion sort, which is just next to the bubble sort. This is insertion sort technique. So in this technique, we'll start with the general situation, like we used to iterate with each and every element, and then we'll just put it in the sorted list, and then the process will go on. That means if we take an array of elements, we are dividing this array of elements into 2 lists. One is unsorted list and other is sorted one. So one element in each step, one element from the unsorted one is taken, and it will be compared with the sorted list, and the element will get inserted. Let us see the example for this. So this is the working example of insertion sort. Suppose consider this array. Suppose let us consider this array. Here we have taken array of 1. It is the size of 8, array of size 8, and here the first element 54 is considered as one list, and the remaining elements, all the elements will be considered as another list. So we are taking the first element, whether we are not seeing the number, we will just take the first element and will consider this as a sorted one, sorted list, and the remaining elements will be considered as unsorted list. So from here, one element in each iteration, one element is taken from the unsorted list, and it will get compared with the sorted element, and if that element is less than is smaller than the previous element, it will be inserted into the list of sorted elements. So from here you can see 26 being taken and compared with 54, as it is less than 54, it is getting inserted into this list. Like the same way the process will continue. Now we will see the number 93, and then we'll compare it with 54 and check if the number is greater, it will remain the same. If not, means it will go into the sorted list. Then the same process will continue for the remaining numbers till we are getting a sorted list of elements which will be inserted within no time. So here the main difference between the bubble sort and the insertion sort is, here we are comparing each element with the sorted element, and as soon as the sorting takes place, we are inserting that element into that list. So there is that is, the time complexity will get reduced. We are not going through all elements at the same time. We are comparing each and every element for each and every iteration, and then only we are moving to the next step. So let us see the simple code for insertion sort. See the simple code for insertion sort. Here, void insertion sort, where we are writing a program for insertion sort where we are sending list as the parameter and the size of the array. These two will be the parameters of this insertion sort function. Here I, j, item are the 3 integer elements we are taking. Okay, now we are writing one for loop to see here we are writing a for loop by starting with I equal to 1 and I is less than size and I plus plus, where I is the number of iterations to be taken, and here in the item, that is the list with the actual value, current value will be saved in the item, and then the for loop and the inner for loop. We are doing the inner for loop for checking the comparisons, and if there is any need of insertion, that all can be done within this insertion code. So from here, if we see the example by using one program, here you can see we have taken this array. Here you have seen like we have taken this array of elements where we are writing a code for printing the elements as it is, and then we are calling an insertion sort algorithm. What it actually does is it will first divide this set of array into two unsorted and sorted lists, and then from the unsorted list it will take each and every element and it will start comparing it with the sorted list, and if there is a need, the element will get inserted. That means it is creating a space that from the last, if we consider it, if the list from the last, then from the last the elements are moving backward, and also in the sorted list the elements are moving forward. So after this insertion sort, we can get the sorted list. So here also, if we see the complexity analysis of an insertion sort, we will consider it in three different cases, like the same way we have considered for bubble sort. If the input list is already in the sorted order, here the number of comparisons will be deferred, because the number of comparisons in which each iteration is 1. That is the number of comparisons in each iteration is 1. As you can see here, the number of comparisons in each iteration is 1. That means we are taking only one element at a time in each iteration, and we are doing the comparison. So the number of comparisons can be given as 1 plus 1 and so on. The process will repeat, because one element at a time to n-1 iteration, and the number of movements will be 0, because the list is already in sorted order. Now in the next case, if the input list is sorted order, but in the sorted list is in reverse order, then we can see here from the slide, like C of n, the number of comparisons will be given by n into n-1 by 2, and the number of movements will also be same as the number of comparisons. And in the other case, if the list is in a random order, then we have to consider the probability of each element which is located in the jth position. Then the average number of comparisons can be given by the formula ai plus 1 is equal to summation of j equal to 1 to I plus 1 j into pj, where pj is the probability of the element in the ith location in the ith iteration and jth location. Then assume that here, as we have seen, the probability will be uniformly distributed. So for each and every position, the probability will be same at a particular, each and every element, the probability will be same at a particular position, which is given by 1 by I plus 1. So the number of comparisons will be given by the following formulae, and the number of movements will continue. So here I am giving you a summary of complexity analysis, in which you can see the number of comparisons for each different cases, and also the complexity time complexity. Here the main difference here you can observe is the time complexity. For bubble sort, For bubble sort, the time complexity was order of n square, where in the insertion sort, the time complexity is order of n for the best case, but for worst and average cases, it is same as order of n square. So it is a little more efficient than bubble sort. If you want to do a sort, if you want to get a sorted list from an unsorted list in a fast manner. So let us see some previous gate questions regarding bubble sort and insertion sort. So the first question, the first question, if you see, assume that the algorithms considered here sort the input sequence in ascending order. If the input is already in ascending order, which of the following is true? So they have given the time complexity for each and every different type of sorting techniques. So by the question, you are coming to know, like if the sequence or the list is in ascending order, that is nothing but it is in a sorted order, then we already know that the time complexity of a bubble sort will be order of n square time, and the time complexity of insertion sort will be order of n time. So the answer here will be 2 and 4. So the answer will be 2 and 4. Likewise, the next question, they have given one array and then they are asking, like, which algorithm out of the following uses the least number of comparisons to sort above array in ascending order. So for this kind of array, and the options are given like insertion sort, selection sort, quick sort and merge sort. But here we discussed about insertion sort, which will be less in time complexity, that is within the power of order of n time we can give the unsorted list into a sorted list. So we have to choose the option A. Okay, thank you for the session. Let us continue in the next session. Thank you.